5. Today we get to the fun stuff about right triangles, and that is trigonometry. So what is trigonometry? Trigonometry is the study of triangle measurements. The study. The study of triangle measurements. Now, what do you think we're measuring in a triangle? Well, what can you measure with a triangle? Angles and? All right, angles and sides. The studies of triangle measurements, so particularly the degrees of an angle or the lengths of the sides of the triangle. Okay? So there are 3 trigonometric ratios from a right triangle. Sine, cosine, and tangent. Okay? Now, sine, cosine, and tangent represent 3 ratios. What's a ratio? It's a fancy word for a what? A fraction, right? So we're going to set up ratios, which are fractions, based on the sides of our right triangles. Okay? So, first of all, when you have a right triangle, you need to locate the hypotenuse. How do we find a hypotenuse on a right triangle? Right, it's the side across from the 90-degree angle. It's also the largest side, right? So in this triangle, ABC right here, little c right here is the hypotenuse, right? And little a and little b are the legs of that right triangle because they form the 90-degree angle, right? So it's the side that does not touch the 90-degree angle. So sine is the ratio of the leg opposite the angle to the hypotenuse. Now, opposite means it does not touch, right? Adjacent means it touches. So if we want to find the sine of angle A, there's angle A up there. Y'all see that? That's angle A. Which side, A, B, or C, is the side, little a, little b, or little c, is the side opposite from angle big A? Little a. Yeah, this is going to be one opposite to A, right? So sine of A is little a over the hypotenuse. Now, what is the hypotenuse of this triangle? Little c. Okay? Now, for B, it's going to be different. For angle B, which is the bottom angle down there, what side of the triangle is opposite, or the leg of the triangle is opposite from big B? Little b. And what's the hypotenuse? C. So the opposite is different depending on which angle you're looking for. Does that make sense? Opposite from big A is little a, opposite from big B is little b. So the opposite is going to be changing depending on which angle you're talking about. Does that make sense? But the hypotenuse is going to stay the same. The hypotenuse is always the hypotenuse no matter what part of the what angle you're going from. All right? So cosine. Cosine. Cosine is the ratio of the leg adjacent to the angle of the hypotenuse. The ratio of the leg adjacent to the angle to the hypotenuse. So it's adjacent over hypotenuse. So for angle A, which side of the triangle is adjacent to A, which means it touches it, but it's not the hypotenuse? Yeah, side B over the hypotenuse. What is the hypotenuse for the triangle? Little c. Okay. And now for angle B, we want cosine of angle B. Cosine is adjacent over the hypotenuse. Which side is adjacent to angle B? Adjacent to angle B. Side A. Over the hypotenuse, which is C. Okay. Now, tangent is the only one that does not use the hypotenuse. Okay? Tangent uses opposite over adjacent. So for A, What is the side of the triangle that is opposite from angle A? Little a means does not touch it. Now, which side is adjacent to angle A but is not the hypotenuse? Little b. Good. And then we find tangent of B. So this time we're doing in respect to angle B. What is the side of the triangle that is opposite angle B? Little b. So that's the numerator. Over what is the side that is adjacent to angle B but is not the hypotenuse? Side A. Y'all see that? Now, do you see how these are reciprocals of each other depending on if it's talking about angle A or angle B? Y'all see that? Do you see something else about sine and cosine? Yeah, sine A is the same thing as cosine of B, isn't it? And sine B is the same thing as cosine of A, isn't it? Yeah, that's always going to be the case. Sine of one angle equals cosine of the other angle. All right, and cosine of one angle equals the sine of the other angle, and the tangents are reciprocals. All right. So here's what we're going to use to help us remember sine, cosine, and tangent and what you put over what, okay? So this sounds like a Native American name or something. So you got to spell it correctly. Ka-toa. SOHCAHTOA. That's an A. Okay. SOHCAHTOA. Write that down. So what do you think the S, C, and T stand for? Sine, cosine, and tangent. Very good. So what do you think O and H stand for? And hypotenuse. Yeah. So that tells you, SOHCAHTOA tells you that sine is your opposite side of the triangle over the hypotenuse. So Paul tells you what? Yep, cosine is adjacent over the hypotenuse. And TOA tells you what? Tangent equals what? Opposite over adjacent. You need to memorize that. ASAP. SOHCAHTOA. If you can't spell it correctly, you're not going to do any good. Sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. Tangent is opposite over adjacent. Okay, so now we're going to see a real life example of a real life triangle. Here it is. And they give me all the measures of that triangle on number one, don't they? Okay, so we're going to start and do everything for angle A. We're going to find the sine of A, the cosine of A, and the tangent of A. Okay, so that means we're going to write the ratios. A ratio is a what? Fraction. So we're going to reduce our fractions if they are not already simplified, which those 12, 5, and 13, I think they'll already be simplified. So sine of A. Sine is what over what? Opposite over hypotenuse. So what is the opposite side from angle A? 5. Good. Over what's the hypotenuse of the whole triangle? I'm going to label that with hypotenuse because that 13 is going to be the hypotenuse for everything. So 5 over 13, not 15. 5 over 13 is sine of angle A. Y'all okay with how I got that? Its opposite side over its hypotenuse. So that means 12 is going to be adjacent. Okay? So cosine is what over what? Adjacent over hypotenuse. So what is the length of the side that's adjacent to angle A that's not the hypotenuse? 12 over the hypotenuse is what? 13. And tangent is what over what? Opposite over adjacent. So what's the length of the side opposite angle A? 5 over what's the side that's adjacent to angle A? 12. Does anybody have any questions about sine, cosine, and tangent for angle A? All right, so now I'm going to erase this, and then now I'm going to do it for angle C. Okay, so I'm going to go ahead and label that. 12 is my opposite from C, and 5 is my adjacent to angle C, right? So sometimes it's easier just label them like that, and you might have to erase and do it a couple of times on each picture, but it helps, trust me. Okay, so sine is what over what? Opposite over hypotenuse. So what is the length of the side opposite from angle C? 12 over what's the hypotenuse of the whole triangle? 13. And cosine is what over what? Adjacent over hypotenuse. Which one is adjacent? 5 over what's the hypotenuse? 13. And tangent is what over what? Opposite over adjacent. So what side is opposite from? 12 over adjacent is 5. So let me just tell you this real quick. Since the hypotenuse is always the longest side, y'all agree with that? Tangent is the only one that might possibly be in proper fraction. Okay? Tangent is the only one that could be greater than 1. Does that make sense? Because the rest of them will have the hypotenuse on the bottom. Okay, but adjacent and opposite might be reversed. So do you see that two tangents are reciprocals of each other? Did you see that sine of A equals cosine C? And that cosine A equals sine C? Y'all see that? Okay. Number two. Now, number 2, did they give you all 3 sides? No. What did they not give you? The hypotenuse. Well, if we know 2 sides of a right triangle, how do we get the third side? We use the what? We use the Pythagorean theorem. Very good. So we're going to use a squared plus b squared equals c squared. And so we're looking for the hypotenuse, which will be the c squared, right? Y'all agree? So 9 squared plus, and y'all have that little space over there to the side. I don't have that. So I'm going to go up top and do it really jumbled. 9 squared plus 12 squared equals c squared. I still have my squares on the board. So 81 plus 144 equals c squared. What is 81 plus 144? 225. Oh, nice. You take the square root. What's the square root of 225? 15. So my hypotenuse is 15. Are y'all okay with that? So if they don't tell you all 3 sides, then you use the other 2 with the Pythagorean theorem to get the third side. All right? So y'all help me. First, we're doing W. What is sine? Opposite over hypotenuse. So what's the length of the side that is opposite? Why is it not working? Okay, y'all, sorry. I don't know what's happening. Okay, now we're spinning. Opposite over hypotenuse. Okay, what side is opposite from angle W? 12 over what's the hypotenuse? Now that will reduce, won't it? Yeah, so if your fraction simplifies, then simplify it. What does 12 over 15 reduce to? 4 over 5. Very good. Divide them both by 3. So what is cosine for W? It's adjacent over hypotenuse, which is 9 over 15. You okay with where we got 9 and 15? What does that reduce to? God, my touch screen and my pen are not wanting to cooperate. 3 over 5. And tangent is what over what? Opposite over adjacent. So what is opposite from angle W? 12 over what's adjacent to angle W? 9. And what is that reduced to? 4/3. So any questions about angle W? Y'all are confused on what's opposite and what's adjacent stuff. You need to stop me right then, okay? So let's do for X. X, sine of X is what over what? Opposite over hypotenuse. Y'all, my touch screen. Now, what side length is opposite from angle X? 9 over what's the hypotenuse of the whole triangle? 15. And what does that reduce to? 3/5. And that should be the same thing as cosine W, isn't it? Yeah. So cosine of X is adjacent over hypotenuse, right? So cosine of X, adjacent is what to angle X? 12 over the hypotenuse is 15. And what does that reduce to? 4/5, which should be the same as sine W, right? And then tangent should be opposite over adjacent. So what's opposite of side X? 9 over what's adjacent? 12, and that reduces to 3/4, and it should be the reciprocal of tangent W, and it is. Okay, let's start number 3 together, then I'm going to let y'all finish it. So, on number 3, did they give me all 3 sides? No. Am I missing a leg or a hypotenuse? A leg. Okay, so I'm just going to call it A squared. So, A squared plus, what's the other leg? 16 squared equals, what's the hypotenuse? 34. So, I'm going to label that hypotenuse. I'll need that in a minute. So, A squared plus, what's 16 squared? Equals, what's 34 squared? 1156, and then I subtract 256. Ooh, nice. So A squared equals 900, and the square root of 900 is 30. So that leg's 30. Okay, so I'm going to let y'all fill in sine, cosine, and tangent for those angles. This is a you try from now on, okay? So y'all finish the chart. Make sure you simplify your fractions if they can be simplified.
What's in green? Match what's in red? No, that's why that's wrong. Please don't ever do that. And you have that before clear that. Okay? Alright, so that's that binomial squared. So you got y equals -1/2 times the quantity x squared plus 6x plus 9 plus 19/2. Alright, so distribute. Y equals -1/2 x squared minus 3x minus 9/2 plus 19/2. What's -9/2 plus 19/2? 10/2, and 10/2 simplifies to. So what we have here.
My day, y'all.
And here's standard. So that's how one convert a form to standard form. Does that make sense? So I'm going to use this equation both ways. Now, in your calculator, you can type this in inverse form if you want to type it correctly. You can type it in standard form. Either way. Does that make sense? To make it easier or less, we're going to type it in standard. Are those okay? Alright, so go to your calculator and clear what you have in there, clear it out. Now here you need to do parentheses, -1 divided by 2, close parentheses, x squared minus 3x plus 2. measurement is one off. Yes? Alright, so I want us to find our, is it a maximum or a minimum? It's a maximum this time. They're gonna be second trace, and let's find our maximum value. So press 4. So you want your left hand to be on the left side, so I'm gonna have to move my cursor to the left side.
All right, if you've got all of your ratios and you have them simplified, check them with somebody. I don't believe I said get on your phone. Not supposed to be touching those during the lesson at all.
So vertex form gives me my vertex, yes? So if I compare this in vertex form,
Y'all check them? We're good? All right, y'all help me out. So first one they did was angle L. So angle L, what sine? What over what? Opposite over hypotenuse. What side is opposite from what side is opposite from angle L? There we go. 30 over the hypotenuse is 34. Is that reduced? Yeah, they're both even, so they're at least divisible by 2. What does that reduce to? 15 over 17. Y'all with me? What's the cosine of L? It's going to be adjacent over hypotenuse. What side is adjacent for angle L? 16 over what? 34. What does that reduce to? 8 over 17. Very good. Tangent is what over what? Opposite over adjacent. So for angle L, what side is opposite from angle L? Angle L. 30. What side is adjacent to angle L but is not the hypotenuse? 16. And those are both divisible by 2. And you get what? 15 over 8. So any questions about those? All right, now we do everything in respect to angle M. Sine M is opposite over hypotenuse, which is what? 16. 16 over 34, which is 8 over 17. Cosine of M is going to be adjacent over hypotenuse, which is what? 30 over 34, which is 15 over 17 again. And then tangent of M is what? Opposite over adjacent, which is 16 over 30 this time, which reduces to 8 over 15. Raise your hand if you got all your ratios correct. Okay, good job. So the way we're going to see this most of the time is we're going to have to use sine, cosine, and tangent to actually find specific side lengths. Okay? We're going to use sine, cosine, and tangent ratios to help us find a particular side. Now, this will be problems where they only give us one side and a right triangle, and they'll give us one angle. But they're not going to give us two sides because then we would be able to use Pythagorean theorem, wouldn't we? Because if we know two sides of a right triangle, we can get the third one with Pythagorean theorem. So they're not going to give us two, they're going to give us one. And we've got to find another one. Now, it says make sure your calculator is in degree mode. Do y'all see that on the back over to the side? Highlight that. Like, color it in good. Put a box on it, arrows to it. Make it stand out on your paper because this is important. If your calculator is not in degree mode, your calculations will be totally way off. Now, I'm going to do it myself. Now, here's how we check it to see if our calculator is in degree mode. Turn the calculator on. Turn it on. Everybody's on. Everybody have a little flashing cursor on there saying it's on. All right, so for those of you that everybody say cursor. Okay, so to check your mode, you're gonna hit mode. Y'all know where the mode button is? Right next to the second button on the top row. Well, the second to the top row, technically. Y'all see it? It's the mode button. Yours might look like mine or slightly different because I've got a color screen up here. All right. So about the third or fourth grade down, you see something that says radian and degree? We don't want radian. So if radian is highlighted on yours like it is mine, you're going to arrow down to that row to where radian is flashing at you. You're going to arrow over to degree, and then you're going to hit enter, and that highlights degree. We got to be in degree mode. If not, you're going to be in radian mode, and you're not going to be able to get those links correct. So is everybody now in degree mode? Okay? So if you arrow down, it'll have degree highlighted. So then you know you're good, right? All right, to get back to the home screen, we're going to hit second mode, and that quits it and goes home. So hit second mode, and you're back to the home screen. Everybody good? Anybody need help? Swapping to degree mode. So every time you turn on your calculator, especially if you get one of mine, because my yellow ones have to reboot themselves every time just about. So every time you get a calculator to do trig, you need to make sure you're in degree mode. So on your state test, if you have a trig problem, make sure you're in degree mode. I won't be able to tell you that. These are trig problems. You need to be in degree mode. I can't tell y'all that on test day. So you got to know that the first thing you want to do when you're graphing calculator on state test day or benchmark day or whatever it is, make sure you're on degree mode. Okay? All right. So now we're in degree mode. So I'm going back to our notes. Let's look at a problem. Let's look. I'm sure we're going back to my notes. Let's look at the back side on number 4. It says solve for x, round to the nearest tenth. So x is a leg of that right triangle, isn't it? Do you see how they gave us an angle measure? What angle measure did they give me? 28 degrees. So I'm going to do everything based off of that angle. So that side x over there, that leg, is that going to be opposite from the 28 degree angle, adjacent, or is it the hypotenuse? It's opposite. And that 19 that they gave me is the what? Hypotenuse. So with SOHCAHTOA, which ratio do we need to use when we have an opposite and a hypotenuse? Sine. We're going to use sine. So we're going to set up a problem like this. Sine, and in parentheses, you're going to write your angle measure, 28. Now we abbreviate the sine, cosine, and tangent to their first 3 letters. This is not the word sin. This is not Sunday school. Okay, this is still sine. You don't say sin, cos, tan. You say sine, cosine, and tangent. Okay? Okay, sine of 28 degrees equals opposite over hypotenuse. Now, what side is opposite from the 28 degree angle? X over which side is the hypotenuse? 19. That's how you set up the problem. Sine of your degree equals opposite over hypotenuse. All right, y'all, this is an equation. It's got a variable in it, doesn't it? Sine 28 degrees is just a number. All right, it's a ratio. So if we're solving this for x, and we want to get x by itself, and they're dividing by 19, how do I get rid of 19? Multiply it on both sides. So you're going to multiply times 19 on both sides. So those cancel out. 19 divided by 19 cancels out, right? So 19 times sine 28 equals x. The rest of it is calculator work. So is everybody okay with how we did the operations to get x by itself? They divided by 19, we multiplied by 19 on both sides. So in our calculator, you're going to write, let's see if I can shrink this calculator. No, just made it disappear completely. You're going to hit 19. And you can hit the time sign if you want to. You don't have to. It'll work without it. The sign button, y'all see the sign button? It's 2 of them up from the 7, isn't it? 2 buttons up from the 7 key. So you're going to hit sign. And in parentheses, you're going to write 28. And then you're going to close parentheses. And you're going to hit enter. And if you're in degree mode, you should get about 8.9. Did it say nearest 10th? Yes?
Mine's in this area.
It's not correct. It's 2 units up. So again, does it say anything about a reflection, a stretch, or a stretch? No. So what is that?
Because
One. Does it say anything about left or right? Yes. It says 7.
do it without the times.
Right. So
Okay.
right, it says positive.
So y'all get about 8.9. Did everybody get that? Anybody not? All right. So you're going to, on your notes, you're going to write X. And we're approximating, so we're going to squiggle it. Approximately 8.9. Now let's see if that makes sense. That was a leg, and it needs to be smaller than the hypotenuse, right? So make sure if you're finding a leg that it's smaller than your hypotenuse. If you're finding a hypotenuse, it's the largest side. Okay? So that's how you do it. So you got to determine which ratio you're using. If it's sine opposite over hypotenuse, if it's cosine adjacent over hypotenuse, tangent opposite over adjacent, and then that's how you solve the equation for x, and then you use your calculator. All right, number 5. Here's my 41-degree angle. So there's the angle they gave me. So I have to determine if I'm going to use sine, cosine, or tangent. I'm going to determine, y'all, we're running out of time. We got a lot to do still. We got to determine if we're going to use sine, cosine, or tangent. Okay? So that x from that 41-degree angle is what? Opposite. 32 is what? The hypotenuse is right here, isn't it? Yeah. So we're not going to use hypotenuse. So this is adjacent. So from SOHCAHTOA, if I have an opposite and adjacent, which one am I going to use? Sine, cosine, or tangent? Tangent. Because I don't have a hypotenuse, do I? So I'm going to use tangent of that angle measure, which is what? 41 degrees, equals opposite over adjacent. So what is opposite? X over what is adjacent? 32. So solve the equation for x. What do we do? Multiply times 32 on both sides. So it's 32 times tangent of 41 equals x. Okay? So in our calculator, that's what we type. 32 times tangent 41. And you could just write 32 tan 41. You don't have to put times in it because if it's squished up like that, it knows it's multiplying. And close parentheses and hit enter. Did y'all get about 27.8? Anybody not get 27.8 when you typed it? All right. And let's see if that makes sense. X is approximately, come on, touchscreen, 27.8. And we don't know the hypotenuse, so we assume it makes sense. Okay. Y'all okay how we did that? So you got to determine which ratio to use and then set it up. Number 6. So we're going to use it based off of this angle. What is the x's relationship to that angle? Adjacent. And the 26 that they gave me is the what? Hypotenuse. Is everybody okay with that? So what do you think we're going to use? Sine, cosine, or tangent? Cosine is adjacent over hypotenuse. So we're going to say cosine 21 equals adjacent, which is what? X over the hypotenuse is what? 26. All right. So how do I get rid of the 26? Multiply both sides by 26. Those cancel out. So it's 26 times cosine of 21. I forgot my parentheses, y'all. Equals x. Calculator. 26 cosine 21. Close parentheses. Y'all get about 24.3? All right. X is approximately 24.3. Is that smaller than our hypotenuse? Yeah. Can y'all try number 7? No, you can. Yes, you can. Y'all try number 7. Because number 8's a little bit more complicated.
Number 26, y equals 3 times cosine of x minus 6 squared minus 2. What's x? What's x? 3 times what 8 is? 3. What's 8? Negative 6 is positive. Positive. Okay. Yeah, this too. That shows your transformations right there. A is positive. There is no reflection when A is positive. Yes?
Now let me know if you get stuck. If you pick the wrong ratio, it's not going to work. You gotta make sure you use the right ratio. Sine, cosine, or tangent. Look at what you got.
Means like horizontal.
You round it and check your answer with a neighbor.
This is positive. So the direction.
So I've got a copy here. Staples it for you.
Yeah, in front and back to the staples. Yep. That's neat.
Wow.
It takes, yeah, I do single sheets most of the time and it puts front and back and staples it. Well, that's old technology. It's fancy when it works. No. Look, it's separated on and then stapled it on one piece of paper. That's how much y'all's practice is gonna look like. All right. So what did y'all use? Sine, cosine, or tangent? Tangent, because the x is opposite and the 8 is adjacent. Y'all agree? Did everybody use tangent? If you did not use tangent, then get out your eraser. Okay. So tangent of 55 degrees equals what's opposite over what's adjacent? 8. Now, how do you get x by itself? Multiply by 8 on both sides. So 8 times tangent of 55 degrees equals x. So what did you get when you put that in your calculator? Approximately what? X is approximately 11.4. Raise your hand if you got x is approximately 11.4. Good job. Now, number 8, it gets a little bit more complicated. Not really, but just the setup of it, it's going to take a little bit more work to solve for x. Okay? So we got a 33-degree angles. X is the what? Hypotenuse this time. And 15 is what to the 33-degree angle? Opposite. Y'all, my Sunday school class, I love them, but this thing vibrates one more time. I'm going to scream. Y'all ever feel like that? Okay. So, this one's opposite. Sine, cosine, or tangent? Sine. We have opposite and hypotenuse. We're using sine. So, sine of 33 equals opposite over hypotenuse. Now, what's the opposite? 15 over the hypotenuse is what? X. Now, how do we solve for x if x is in a denominator? Well, first we got to get it out of a denominator, right? So if it's dividing by x, how do we move x? Multiply by x on both sides. So those cancel. So I have x, God, my touchscreen. X times sine 33 equals 15. Now, x is not by itself yet. It's multiplied times sine 33. So how do I get rid of sine 33? Yeah, divide by sine 33 on both sides. So this one takes a little bit of work, like I said, to solve for x. And then those cancel out. So x equals 15 divided by sine 33. Y'all see how I got that to get x by itself? I multiplied both sides by x to get x out of the denominator, and then I divided both sides by sine 33 to get x by itself. Okay? So now when we type this in our calculator, we're going to be a little bit careful. Hit 15 divided by, and then I would use parentheses, sine 33. And since you have two open parentheses, you need to close two parentheses. Does that make sense? So use your parentheses. And parentheses are above the 8, 9. So 15 divided by parentheses sine 33, close it twice. And hit enter. Y'all get about 27.5? Okay. So x is approximately 27.5, which should be the longest one because it was a hypotenuse. And it is longer than 15. Okay. So those are the same thing, except for there's just a little bit more work to get the variable by itself. So look at number 9. 43 degrees. X is the what? Hypotenuse. And 36 is what to our 43-degree angle? Adjacent to it. So what do you think we're going to use? Sine, cosine, or tangent? Cosine. Very good. So cosine of 43 equals adjacent over hypotenuse. So what's adjacent to the 43-degree angle? 36 over what's the hypotenuse? X. So first we have to solve for x. So how do we solve for x? Yep, got to multiply by x on both sides to get it out of the denominator. So x times cosine 43 equals 36. Now what? Then you divide by cosine 43 on both sides. Now technically you don't have to write down this next step, but I'm just doing it to keep it neat. So I know exactly what to type in my calculator. So in our calculator, we're going to say 36 divided by parentheses cosine 43. And I close it double. Hit enter. Getting about 49.2. Did y'all get that? 49.2. And that's supposed to be the hypotenuse again. Is that longer than the other side? Very good. So any questions on those? I know it takes a little bit more manipulating to get the x by itself, but it's just algebra. Don't be confused about all those extra letters. Okay. Can y'all try number 10 and we'll call it the last one? We're going to skip the word problems and do one day of just word problems next week. So we're going to do all of our word problems. Yes.
Do 36. You get some. And I plotted these 3 things. I actually started with the first, to be honest with you. So you start with -3 0. That's right here. Is that on that problem? No, there you go. That's your choice B. -3 0. Right on that, and I'm gonna keep it. -3 0. Right on that, and I'm gonna keep it. -3 0. Not on this one, I'm not keeping it. Again, we're down to 2 answer choices and we
What
go.
is maybe some of my benchmarks?
All right, go back to 5, 0, 5, 0. So we eliminate that. So there's 5, 0, that works. And there's 5, 0, that works. So then it says you have a y-intercept from 0, 8. So y-intercept from 0, 8, we go up 8 to get to that, yes? And so far, that drives matches. Let's go back to the subject. Here's 0, 8. Yeah, now? No. And I don't know how to start over pairs, don't you? Yeah. What are you doing that? I will, it's funny. Don't know why. Here's this. Let me get it on the screen first. Fractions are always funny. Like, fractions are always. It's like fractions are always. It's just extra fun. You think so?
It's so cute that y'all thought I was saying things like that. I love y'all, but. If I had to say well these by hand all the time, y'all wouldn't get handouts, y'all have to copy everything.
I was fair and everything.
That's not fair. Or love. History.
For you. What do you think I had to do?
Now you can read
At least I did have it
it.
ready. I only messed up two practice.
What are something to that is greater than anybody?
Y'all check in with each other.
So if I just glance through. Now.
Dang
If I just glance through, you're already working back.
Okay, so the x is what in relationship to the 72-degree angle? Adjacent to it. And 25 is what? Opposite, because it's not the hypotenuse, is it? So which one are you going to use? Sine, cosine, or tangent? If you didn't use tangent, get out your eraser, okay? So tangent of 72 degrees equals opposite over adjacent, right? What is opposite? 25 over what's adjacent? How do we get x out of the denominator? Multiply by x on both sides. So x times tangent of 72 degrees equals 25. So how do I get rid of tangent 72? Divide by tangent of 72 degrees. And my calculator, 25 divided by tangent. I didn't put parentheses, but we'll see if it works. I think it does. Did y'all get about 8.1? Raise your hand if you got about 8.1. Any questions? All right, x is approximately 8.1. Very good. All right, so that is the end of notes for today. Have a good one.